Hi, everyone. My name is Clint Wyckoff, and welcome back to another episode of AWS Supports You. I'm an enterprise support manager based out of Pittsburgh, Pennsylvania, and here at AWS Supports You, we provide experts that are going to give us some tips around optimization of performance, lowering costs in the cloud, as well as giving best practices and design considerations. Joining me today is Sukhmita from AWS Enterprise Support. First off, Sukhmeet, welcome to the show, and why don't you give us a quick introduction?
Hey, good morning, Clint. Good morning, everyone who's tuning in. My name is Sukhmeet Mata, and I'm a senior technical account manager based out of US East. I'm a specialist in machine learning and AI, and my area of depth or core is computer vision. So we'll be talking about Amazon Rekognition today. Once again, Clint, thanks for the opportunity.
Fantastic. And like I said, Sukhmeet, welcome to the show. It's great to have you here. Everyone, so as Sukhmeet did allude to and let the cat out of the bag there, we're going to be focusing today's conversation around diving deep into Amazon Rekognition. This is Sukhmeet's area of expertise. We're also going to be sharing how a TAM from Enterprise Support was able to help one of our customers in developing an end-to-end proof of concept with great results. So you'll want to stay tuned for that. But before we get into the details, a quick note to the attendees online, please feel free to use the chat window off to the right-hand side of the screen. Also, let us know where you're joining us from and post questions that you might have for us along the way. We look forward to hearing from you. If you have any questions or anything like that, like I said, post those in the chat where you can give us feedback by taking our quick online survey. With those few administrative items out of the way, Sukhmeet, let me throw it over to you. And why don't you take it from here?
Of course, thanks, Clint. Just making sure you're able to see my screen before I go ahead.
Yes.
Awesome, thanks. So once again, good morning, good afternoon, everyone. My name is Sukhmeet Mara, and today we'll be diving deep into Amazon Rekognition. I'll go over the agenda and table of contents first. Here's what we are going to cover today. Today, we'll talk about the AWS ML stack, which is the machine learning stack. We'll do a quick introduction to Amazon Rekognition. Once we are done with the introductions, we'll talk about certain use cases, features, common applications of Amazon Rekognition. And then we'll go over a success story of enterprise support, how a TAM helped one of their customers to create an end-to-end POC in less than 4 days. And then we'll go over Amazon Rekognition APIs. So our mission at AWS is to put machine learning in the hands of every developer, right? To do that, what we've done is we've taken a 3-layer approach to machine learning, which we internally call the ML stack or the machine learning stack. If you see at the bottom layer, that's what we call the frameworks and infrastructure layer, right? This is where expert machine learning practitioners who are comfortable with building, tuning, training, deploying, and managing models themselves, they can develop and deploy their own machine learning models. So this layer consists of PyTorch, Apache, MXNet, TensorFlow, or you could bring in your own code, your own Docker containers, or you could use any of the instances or GPUs, right? So this is our ML framework and infrastructure layer. In the middle layer, we have what we call the machine learning services that make it easy for machine learning developers and data scientists to build, train, and deploy machine learning models in a single click with Amazon SageMaker. SageMaker removes the heavy lifting, complexity, and guesswork from each step of machine learning process, empowering everyday developers and scientists to successfully use machine learning. So this layer, the ML services layer, consists of SageMaker Canvas, Studio Lab, and the IDE as well, right? This helps you prepare data, store features, detect bias, hyperparameter optimization or tuning, helps you deploy in production and explain predictions as well, which is really powerful. And in the top layer, as we speak, this is the AI services layer that allows all developers to use pre-trained and auto-trained machine learning models and add intelligence to any application without machine learning expertise. These services make it really easy to incorporate AI into applications without having to build and train algorithms. As you can see at the far right, under the vision section, Amazon Rekognition is one of these AI services, right? These AI services are divided into two sections. One is the core AI services that takes care of text and documents, chatbots, speech, and vision, and the specialized AI services you could use for business processes, things like Amazon personalized forecast, so on and so forth. Or there's industrial verticals, right? Something like Amazon Monitron, or healthcare like Amazon Health Lake. So this is our three-layer approach that we've taken to the AWS ML stack. So here's the big question. What is Amazon Rekognition? Amazon Rekognition is a deep learning based image and video analysis service, right? Amazon Rekognition makes it easy to add image and video analysis to your applications using proven, highly scalable deep learning technology that requires no machine learning expertise to use. With Amazon Rekognition, you could identify objects, people, text, scenes, and activities in images and videos, as well as detect any inappropriate content and remove inappropriate content from the images or videos. Amazon Rekognition also provides highly accurate facial analysis and facial search capabilities that you can use to detect, analyze, and compare faces for a wide variety of user verification, people counting, and public safety use cases. As we say, an image speaks 1,000 words. If you see this image towards the left, this is the image that was supplied to the Amazon Rekognition object detection or scene detection API, right? And if you see the image on the right, that's the predictions that came out of the Amazon Rekognition service. It's able to predict with a high confidence that this is a person with a 99.3% confidence who's riding a bike with a 99% confidence. And there's some other labels that came out as well, like rock, crest, outdoors, so on and so forth. So this is the power of Amazon Rekognition. So Amazon Rekognition provides multiple APIs for image and video analysis that return various different types of visual metadata depending on the API call that a customer makes. As you can see, you could do object, scene, and activity detection. You could have your own custom labels. You could do content moderation. You could detect text in the wild, PPE detection, face detection analysis, face compare and search, celebrity recognition, video segments, pathing, so on and so forth. So, in summary, with Amazon Rekognition, customers can identify objects, scene, and activities, meaning detect thousands of objects and scenes, plus activities such as if somebody is delivering a pizza or if someone's playing soccer. You could perform face analysis, face search, and face comparisons. You could identify well known celebrities and add well known people to catalog photos and footage for media, marketing, and advertising. You could detect and remove unsafe content. You could detect text in the wild, meaning if you see the people in the top right, there's runners with the badge numbers. You could detect text in the wild and use that information. Or you could use distorted text from images and videos of street signs, social media posts, and product packaging. You could perform person pathing, meaning person one is passing the ball to person two, and also monitor live streams using Amazon Kinesis video to detect and recognize faces from face data that you provide. Also, some common applications of Amazon Rekognition. You could do workplace safety use cases like PPE detection, vehicle or person detection, POI. There's out of the box use cases for identity verification, meaning test taker fraud detection, know your customer, media analysis. There's industrial and retail verticals as well, where you could do parts classification, inventory management, damage detection, so on and so forth. So, in summary, Amazon Rekognition supports thousands of labels belonging to common categories, including but not limited to people and events, food and drink, nature and outdoors, animals and pets, home and garden, sports and leisure, so on and so forth. Meaning you could look at scenes, objects, labels which are out of the box, and if some labels are not supported out of the box, we have Amazon Rekognition custom labels that you can use to create your own custom labels and create your own POCs for your business use cases. A big question, why Amazon Rekognition? There's three fundamental reasons why someone would use Amazon Rekognition. It lets you build faster, simplifies your operations, and customize easily. At the end of the day, it lets you innovate at the speed of your business needs, right? So when I say build faster, it there's ready to integrate SDKs and APIs. You get high quality results, and there's no machine learning expertise required. With simplify operations, there's no machine learning models to build or manage. There's no data teams required, and you get continuous improvement. And you could customize easily, meaning if there's labels that are not supported out of the box, you could use Amazon Rekognition custom labels and detect business specific labels and also run trained models in your account. A quick fact here, right? Another reason why you would use Amazon Rekognition is in November 2021, Amazon Rekognition reduced prices of all image APIs by up to 38%. I'll take a pause here, Clint, to see if there's any questions coming out from our audience.
Yeah, hey, Sukhmeet. So we do have a question. We'll get to that here in a second. So, the why of Amazon Rekognition, I think, is important, and the fact that it's a managed service, so the customer doesn't have to write any of their own, machine learning models, and they get the true benefit of the cloud, which allows them to build and innovate faster and really simplify operations. You talked a lot a minute or two ago about some of the different use cases, and that's actually where the first question comes in from JibJab06, and they asked, could recognition be used in a warehouse environment to track packaging and help optimize pathing?
Most certainly, and there's a classic use case for one of our customers. I'll shed some light on that. I'll not go into the details of who the customer is, but in this particular use case, what happened was, every barcode has some information attached to it, right? So what the customer was doing was they were scanning barcodes with the Cobra guns or the QR barcode scanning guns, which was integrated with their warehouse management system, which is a WMS, right? Warehouse management system. When they would scan the barcode, it would tell the person that this package needs to go in a particular bin. In this case, let's say package with a QR code or a barcode A1234 needs to go into the bin A4, for example. What that did was it helped them optimize their entire pick, pack, ship process, meaning once they scan a barcode, they would know what is an optimal place for this package to be kept into, meaning package A1234 goes into bin A4. So that optimized their end-to-end process. It also helped the warehouse operator to figure out where each package needs to go, thereby saving time as well as optimizing the entire pick, pack, ship process. That's number one. The customer also wrote some business logic, meaning it was connected to the WMS systems. With this business logic, they knew where every package was, they knew the quantity, they knew the inventory. So it also helped them with inventory management as well. So at the end of the day, they optimize their entire workflow and also optimize pathing as well.
It's fantastic. A lot of times whenever we think of recognition and even talk about it, we give the examples of, native image recognition, like this is a person or the person is wearing, PPE material. This is a little bit of a different example there where you're managing, items within a warehouse and you're scanning barcodes based on an event-driven architecture, and recognition is a piece of that puzzle.
100%, yes. And I think the art of the possible, I think when we give examples of if you could detect a birthday party or a birthday cake, I think those are all hello world and starter examples, right? But
Right.
businesses have matured and have used Amazon Recognition for really high level or really complex use cases where businesses write their own complex queries. So once Amazon Recognition does its magic and gives you an output, and you rightly summarized, there's an event-driven architecture that a lot of our customers would use and rely on those metrics or the outputs from Recognition or Amazon Recognition to run their business logic so that they could optimize either binning or putting away their packages, so on and so forth, right? So I think great summary there as well.
Perfect, Sukhmeet. There's no other questions, so feel free to take it away, and we'll check back again in a few minutes.
Thanks, Glenn. So since we did a quick introduction to Amazon Recognition, up next we'll talk about use cases and features of Amazon Recognition. In this section, we'll talk about media discovery as a vertical, right? With media discovery and Amazon Recognition, you could look into live events, create your own media libraries, look at social media, and also do influencer marketing. What I mean here is, you could automatically extract meaningful metadata from your media assets. Computer vision enables digital media professionals to generate valuable insights at a quick pace and at a lower cost by automatically identifying the contents of images and video. Amazon Rekognition can identify objects, people, text, scenes, and activities, as well as detect and remove inappropriate content. These features make it possible for media and entertainment professionals to easily extract metadata from their content and then use the metadata to create innovative solutions. For instance, customers can use the extracted metadata generated from Amazon Rekognition to create a searchable asset library, or moderate image and video content, or perform audience sentiment analysis, so on and so forth. So that's the power of Amazon Rekognition. Some tools for media discovery. Amazon Rekognition helps you answer a few important questions here: the who, what, and where. Who, meaning which celebrities or who are the celebrities in the image or video. What labels were detected from this image or video, meaning whether the celebrity is walking on a red carpet or if they're playing soccer. And where, meaning where the scene is occurring. Is it in downtown? Is it on a Broadway? So on and so forth. So, in summary, Amazon Rekognition makes it easy for customers to automatically recognize tens of thousands of well known personalities in images and videos using machine learning. We are talking about celebrities. Here we'll talk about celebrity detection. As you can see, when Amazon Rekognition is supplied with this image, it's able to predict with a 97% confidence that the person on the left is Wendell Pierce, the person or the celebrity on the right is John Krasinski, with a very high confidence of 97% and 99% respectively. Amazon Rekognition quickly identifies well-known people in your video and images. There's higher accuracy now and increased coverage of global celebrities, and then three new attributes have been added for celebrity recognition, meaning you could do presentation of gender, expression, smile, so on and so forth. We'll talk a little bit about object and scene detection here. As I said earlier, an image speaks thousand words, right? Amazon Rekognition automatically labels objects, concepts, and scenes in your images. And you've heard me talking about labels and tags. I just wanted to quickly give a overview of what a label or a tag is, right? A label or a tag is an object, scene, action, or concept found in an image or video based on its contents. For example, a photo of people on a tropical beach may contain labels such as a palm tree, which is an object, a beach, which is a scene, running, which is an action, and outdoors, which is a concept. Besides that, you could also detect people and events, meaning if there's a wedding going on, if there's a bride in the image. You could detect food and drink, meaning you could talk about apple, sandwich, wine, pizza. All of that can be detected natively. Nature and outdoors, meaning you could detect beach, mountains, so on and so forth. There's a bunch of categories that you could detect. And if you go to the FAQ section or the Amazon Rekognition documentation, there's a list that tells you all the different categories and the labels that are available out of the box. Now let's talk about object and scene detection here. What's happening in this image? So if you run this image through Amazon Rekognition, it's able to predict with a high confidence that this is a person with a 98.3% confidence who's on a skateboard with a 94% confidence. There's a bunch of automobile, and then there's asphalt. There's other labels that come out of as well of Amazon Rekognition. It's able to predict that this is some kind of sports. There's architecture, there's parking, transportation, so on and so forth. Another set of results predict that this is probably downtown, there's this road, and in a city, right? And I was talking about bounding boxes. Uh, if you see, a bounding box is what and is how an object is detected, right? So the person is detected and there's a bounding box around that person. So bounding boxes specify the location of common objects such as dogs, people, skateboard, car, so on and so forth. You can use bounding boxes to infer how many of each object exist in an image and the relationship between the objects. For example, how many persons are there in this image? Or If there's a person on a skateboard, that's a relation between a person and a skateboard. So it is really powerful. It can do scene detection. Uh, let's talk about face use cases here, right? You could recognize your customers, meaning verify the identity of your customers who opt in, and also conduct customer analysis or analyze trends. With face use cases, there's two primary areas that we focus on. One is face compare and search, meaning determine the similarity of a face against another picture or from your private repository. The other area is face detection and analysis. Detect faces appearing in images and videos and recognize attributes such as if the eyes are open or if someone's wearing glasses or if they have facial hair, so on and so forth. Talking about customer analysis, here you can see the person on the left. If you supply this image to Amazon Rekognition, it's able to predict whether the person is wearing accessories. The person is wearing sunglasses with a 99.5% confidence, and it's able to predict that the person is smiling or driving, right? On the right, if you see, it's able to predict accessories that this person is wearing. So it's able to predict whether the person is wearing glasses. So Amazon Rekognition, object, scene, and activity detection can help you find customers' social media posts about your products. That's very powerful. Looking at some other trends here, it's able to predict with a 99.9% confidence that this is a female between the age of 26 to 43 years old and the person is smiling. And if you look at the person on the right, it's able to predict that this is a male between the age of 49 to 69 years old who's not smiling, probably because he's serious about his life. And then he has a mustache and a beard. So Amazon Rekognition helps you learn more about the customers who are using your products. You could easily identify and analyze demographics, emotions, style, facial pose, and landmarks. We've spoken a lot about Amazon image recognition. We'll talk about video here. So I'll talk about video segmentation here. Video segmentation can help you detect key segments in videos such as black frames, start or end of credits, slates, short detection, color bars, so on and so forth. Amazon Recognition Video provides an API that identifies useful segments of videos such as black frames and end of credits. Today, companies use large teams of trained human workforces to perform tasks such as finding where the opening and end credits are in a piece of content, or choosing the right spots to insert advertisements, such as in silent black frame sequences, or breaking up videos into smaller clips for better indexing. These manual processes are expensive, slow, and can't scale up to keep up with the volume of content that is produced, licensed, and retrieved from archives daily. You can use Amazon Recognition Video to automate operational media analysis tasks using fully managed, purpose built segment detection APIs powered by Amazon Machine Learning. By using the Amazon Recognition Video Segment APIs, you can easily analyze large volumes of videos and detect markers such as black frames or short changes. With all of these, you get SMPTE time codes and timestamps, meaning Society of Motion Picture and Television Engineers framework, or the standards that are followed by SMPTE. So you get SMPTE time codes, timestamps, and frame numbers from each detection. Again, no machine learning experience is required. One of the classic use cases is PPE detection or personal protective equipment detection. You could analyze images to detect if persons are wearing face covers, head covers, and gloves or hand covers. As you can see in this image, Amazon Recognition is able to predict that the person is wearing head cover, there's a face cover, which is a mask, and a hand cover, which is a glove, right? So Amazon Recognition is easily able to predict that. So Amazon Recognition can detect PPE worn by persons in an image. You can use this information to improve workplace safety practices. For example, you can use PPE detection to determine if workers on a construction site are wearing head covers or if a medical worker is wearing face covers or mask, and gloves. To detect PPE in an image, you can call the Detect Protective Equipment API and pass an input image. The response is a JSON structure that includes the following: the persons detected in an image, the parts of the body where PPE is worn could be face, hand, head, left hand, right hand. So you get that minute detail from that image and help understand how your workers are, adhering to the practices or safety standards. The types of PPE detected on the body, meaning face cover, hand cover, gloves, etc. For items of detected PPE, an indicator for whether or not the PPE covers the corresponding body part, meaning is the right hand covered with a glove, is the left hand bare, or if the person is wearing gloves, so on and so forth. So you could go into such kind of depth and understand and help your workplace be more secure. Clint, I'll take a pause here before we move on to the next section to see if there's any questions.
Yeah, hey Sukhmeet, that was a lot of information, a lot of different use cases around that folks might be interested in utilizing Amazon Rekognition. If you are utilizing Rekognition for any of those different areas or any use cases, throw those in the chat. Interested in hearing about them. So we do have a question that came in here from Fox Titus, and their question was, how's the privacy of data handled in the context of teacher-student engagements in a classroom?
I think that's a brilliant use case. To begin with, I just wanted to set the foundation right. Again, working with Amazon and AWS, there's a shared responsibility model. That's the number one thing to know about. But fundamentally, your data lives on a S3 bucket, right? So it's secure by default, right? You have to make sure that you know, you apply all the necessary security on the S3 buckets. That's where your data lives. Again, you have to write some business logic at the same time, meaning a teacher A in a class A should only have access to those group of students in class A, which means that teacher B shouldn't have access to the conversation between teacher A and student A from a class A, right? So shared responsibility as well as constructing the business logic helps keep you secure. An important point here is Amazon is very serious and AWS is very serious about privacy and security of the data. Your data lives with you and it's yours to keep. You could also opt out as well, meaning Amazon Rekognition and Amazon services use or could use your data to improve our services. But once you opt out of that, your data will not be used for improving our services. So, two or three important points to note here. Clint, I hope that answers your question.
Yeah, that's great. All those are very valid points. The shared responsibility model, setting up a layered approach to security and making sure that only the necessary folks have access to the items that they should have access to, and then also having the ability to opt out, especially if there's any um, you know sensitive information or PII or minor type information in there from like a school student perspective. Very important. So Mike Adam 123 asks, to search a face, should we use the face compare or search face in collection with indexed faces? Specific API question.
Yes, I think I was going to do this when I cover the API section. But
Mm-hmm.
again, just for the sake, since we're taking a break here between sections, I think here's my response, right? Amazon Recognition supports the index faces operation, right? What you can use this operation to detect faces in an image and persist information about facial features that are detected into a collection. Again, the index faces operation detects faces in an input image that could be a JPEG or PNG and then adds them to the specified face collection. So index faces can detect that, whereas you would use compare faces API operation in a source image with faces in a target image, right? When you want to compare the faces. So index faces for detecting faces and compare faces API to compare the faces. So again, the scope of this comparison is limited to the faces that are detected in the target image. So that's an important point here. So I hope that answers the question. So again, I know Mike Adam 123 mentioned face compare, but it's rather compare faces API. So just wanted to put some clarity there as well. Clint, I hope that
Perfect.
answers the question.
Yes, it does. And then I believe you said you're going to follow up on a short talk on the APIs here in a few minutes.
Yes.
Mike had a second question, Sukhmeet. Does Rekognition support user input corrections to recalculate some faces from a picture?
So there's two or three important points to note here. We could use Amazon augmented AI, which is the human in the loop, to improve your data set, meaning you could, annotate your data set again. You could do image augmentation, meaning, let's say if Clint's and my image, let's say we are doing a image classification where we have an image of Clint and Sukhmeet, right? Now you have just two images. With image augmentation, you could convert like an RGB or a colored image to a black and white, grayscale.
Mm-hmm.
Now, all in all, you have six images. So your data set grew, your data quality grew, your outcome or the results from Amazon Rekognition are going to be better. That's number one. Some things to note here is, Amazon Rekognition works across a wide variety or a wide range of image resolutions. For best results, we recommend using the VGA resolution, which is 640 by 480 or higher. Again, going below QVGA, which is 320 by 240, may increase the chances of missing faces, objects, or inappropriate content, although Amazon Rekognition accepts images that are at least 80 pixels in both dimensions. It could be 80 by 80, but again, the recommended size would be VGA, which is 640 by 480. So two important points to note here. One, you could do image augmentation and have a human in the loop pipeline. And
Mm-hmm.
two, look at the recommendations from a resolution perspective, which is at least use a VGA. Another important point for our face use cases, let's say if you're trying to recognize my face in a panorama image, right? My face in the image should at least cover 5% of the entire image for Amazon Rekognition to make a good prediction. Again, uh, every data set differs, but adhering to these best practices will, result in good outputs or good predictions.
Perfect. We have one last question here. It should be a pretty quick one, Sukhmeet. Is there an AWS service that allows to add on top of your clean face different accessories or sunglasses? The example that they gave here is like Ray-Ban does for different models of their sunglasses.
Yeah, I think there's a AWS service called AWS Sumerian.
Mm-hmm.
You could create AR, VR, and MR experiences with that, and it can be used in conjunction with many AWS machine learning services like Amazon Recognition. So when you do face recognition, let's say in a classic world of face recognition, right? There's things like HAR cascades or uh, uh, I I forget the name, but there's here it goes, the facial landmark detection, right? Now, what Ray-Ban would do in this case, for the sake of this example, there's facial landmarks, meaning once a face is detected, there's landmarks like eyes, cheeks, eyebrows, so on and so forth. So Sumerian would help you detect those landmarks and place something like a sunglasses at the right place. So it would place it on your eyes rather than on your forehead or your chin, right? So face detection with landmark detection with Sumerian will help you do that.
Nice. And I threw a link to the Sumerian FAQ there in the chat, and it looks like Sukhmeet that service is being users are being redirected to utilize AWS Amplify in the future.
Got it, got it. I think great point there and great call out, Clint. Thanks.
Perfect. So that wraps up the questions for now. So feel free to continue along.
Awesome. Thanks, Clint. I think we've spoken a little bit about introduction to Amazon Recognition and some classic use cases. Here, in this section, we'll discuss about how enterprise support, a TAM like myself, was able to help our customers, in building an end-to-end proof of concept with Amazon Recognition. So before we get into the details of what the customer achieved and how the entire engagement worked out, I just wanted to lay out the landscape, right? What happened and how enterprise support TAM came in and helped the customer. So here's the use case, right? This was a two-step or a twofold use case that the customer was doing. This was a classic image classification use case and an object detection use case. Again, not going into the details of who the customer was or what they were trying to do, but for the sake of this discussion, I'll pick or I'll throw in an analogy or a similar use case, just so that our audience can understand. So here, this was a classic QA or a QC use case in a manufacturing facility, right? A part is coming off of the conveyor belt, and they want to identify or classify what kind of part it is, whether it's the, let's say, model X or a model Z, for example, or a model K, right? There's three models, let's say. They want to classify which model came out of the production belt on the conveyor belt, and then identify if all the parts exist on this model. For example, let's assume a PCB. A PCB could have thousands of resistors, capacitors, uh, transistors, so on and so forth, right? Or LEDs, right? Let's say for the sake of simplicity, the object detection would like to identify the number of LEDs and identify which parts are missing. So in real time, the customer was able to identify whether the part was X, Y, or K, for example, and then also identify the missing pieces so that they could resolder couple of LEDs back if they are missing, so on and so forth, right? So just for the simplicity and the sake of this discussion, I wanted to bring this example up. So in this case, the customer had about 300 sample images. They went with the classic approach of 80-20, meaning 80% of the images were used for training and 60% or 20% of the images were used for testing and validation. Here's what they were doing. They were manually adjusting the convolutional neural network architecture. That's a lot of overhead with, with manually adjusting, and then doing hyperparameter tuning, so on and so forth. They did around 15 plus experiments, meaning they used a bunch of different CNN architectures from the model zoo, and the end result was their precision was about 72% and the recall was about 54%. There's no way that this could have gone into production. So here's how the technical account manager, which is myself, how we identified the bottlenecks in this process, right? Here, the customer was using manual machine learning or manually training machine learning models, which is a lot of overhead. The experiments were being conducted on local machines. Uh, to, to use a deep learning technology or a neural network, it's highly advised that you would use a GPU or use a high powered or in-memory CPU, right? That complements with GPU. This took a lot of time, and that's a good segue into how time-consuming their entire image tagging and annotation process was, right? It took them a lot of time to tag images and annotate images. And one of our questions that came up is earlier on from Mike Adam 123 was corrections in the calculations, right? There's always a need for human in the loop. So the customer didn't have any augmented AI in the loop, meaning the model is predicting something, but there's no scope of improvement because nobody is improving on the existing predictions or the data set. There was a shortage of images, as well as they didn't have image pre-processing pipelines. They didn't have a deployment pipeline, and they would have to scale and serve these models manually or use different techniques like auto scaling groups. But again, there's a lot of manual knob shifting here. So here's what happened when there was a proactive engagement from a TAM. um, the TAM went into the meeting and helped conduct a quick POC to showcase Amazon recognition capabilities and suggested the customer use Amazon recognition. At the end of the 4-day engagement, the customer had an automated machine learning training pipeline. They ended up using Amazon recognition custom labels so that it adheres to their business use case. They ended up training the models in Amazon recognition itself. They had an image augmentation pipeline using Amazon SageMaker's Keras pre-processing. So they used Amazon SageMaker notebooks and ended up using Keras pre-processing pipelines for image augmentation so that the quantity of images grew and the results got better. Deployment and serving of the models was taken care by Amazon recognition. And they had continuous improvement using Amazon augmented AI, which means there was a human in the loop. Let's say a transistor was predicted as resistor, the human in the loop could go back, look at that sample, change from resistor to transistor or back and forth, and then use that again to retrain the model. So that gave feedback as well as improved results. And then at the end of the day, there was end-to-end POC in less than 4 days or around 4 days. Here's the big results. The precision went up to 97% and the recall went up to 94%. That was a big win for the customer. Clint, before I go ahead to the next section, I just want to take a pause here to see if there's any questions.
No, there was no questions, and there's some fantastic results, Sukhmeet.
Thanks, Clint.
Feel free to continue along.
Thanks, Clint. So we'll talk a little bit about the Amazon Rekognition APIs. There's 4 different sections in the Amazon Rekognition APIs, but I'll cover 3 today just for the sake of being cognizant of everybody's time here. So the Rekognition APIs are divided into 4 sections, but the 3 sections, as you can see here, are the Amazon Rekognition Image APIs, Amazon Rekognition Custom Label APIs, and Amazon Rekognition Video Stored APIs. There's so many different calls you can make to Amazon Rekognition. Things you could do things like compare faces, the kind of example or question that was asked earlier, or detect faces, or index faces from the collection. Using custom labels APIs, you could describe your data set or list data set entries or start product project version, so on and so forth. So all of this is a lot of information here. So what I've done in the next 2 slides is I've tried to identify or showcase 2 classic use cases and the APIs related to those use cases. So here you can see if the image on the left is where the person is celebrating their birthday with a birthday cake, right? If you supply this image to Amazon Rekognition and use the detect labels API, before I go to what the detect labels API predicts, let's look at the API call that is being made, right? So you specify the image bytes, which is a blob. You specify the S3 object, which is the bucket name, the version, and then the max number of labels that you want to detect, and the minimum confidence, right? So let's say you want to filter out everything that's less than 50% or 75%, depending on the use case, right? So anything that's predicted with a lower confidence can be filtered. Once you pass this image to the detect labels API, this is what you get. You get the labels that were predicted with the confidence score and the name of the label, right? So in summary, it's able to you could detect instance of real world entities within an image, could be JPEG or PNG, provided in an image, right, or provided as an input. This includes objects like flower, tree, and table, events like wedding, graduation, and birthday party in this case, or concepts like landscape, evening, nature, etc. For each object, scene, and concept, the API returns one or more labels. Each label provides the object name, the level of confidence that the image contains. For example, suppose the image has a lighthouse, right? There could be, so if you imagine a lighthouse, there could be labels like lighthouse, rocks, sea, birds, etc. Right? So think about a scene or a scenario, and pass that to Amazon Rekognition. You'll get a bunch of different labels that were predicted. So that's what you do with Detect Labels API. Up next, I want to cover another API for the video section here, right? So the start label detection API is again, this is a 2-step process. So what this does is it starts asynchronous detection of labels in a stored video. Amazon Rekognition Video can detect labels in a video or instances of real world entities. Start label detection returns a job ID which you use to get the results of the operation. When label detection is finished, Amazon Rekognition Video publishes a completion status to the SNS topic or the notification channel specified in the API call. Once you have the job ID and the success metric come out to the SNS topic, you run the get label detection. What this does is it gets the label detection results of a Amazon Rekognition video analysis, which was started by the Start Label Detection API. So when you call the get label detection and pass the job ID from the initial call, the get label detection returns an array of detected labels sorted by time, right? So let's say Lighthouse was detected at 3 minutes. So you get the label Lighthouse at 3 minutes. So it's all sorted by time. So you could go to from 0 to all the way to the end of video and detect the labels with the timestamp. The labels returned include the label name, the percentage confidence, and the time that the label was detected, right? So this is a very important parameter here. So just wanted to quickly run over this scenario as well. So Clint, that brings me to the end of the topic here. Any questions that came up during my presentation, I'd be happy to take them now.
No, Sukhmeet. Actually, there's no further questions. And if anybody does have any items that they'd like to throw in the chat, please feel free to drop them in there, and we'll we'll answer them before we close out. However, in the meantime, just a quick recap of what we talked about today was a deep dive into to Amazon Rekognition. Sukhmeet covered lots of different use cases. We also talked about an AWS enterprise support customer that was able to use Rekognition to approve their image recognition use case. If there are questions that you do come up with after the fact that we were not able to answer today, you can post your questions at repost.aws, where one of our experts can provide you with an answer to your question, or who knows, your question just might be a topic for a future AWS Supports You episode. If you do have feedback for us, please check the chat box on the right for a link to our survey, or you can email us at awssupportsyou@amazon.com. We definitely want to hear from you. Let us know what you think, what you like about the show, what you don't like about the show, or topics for future episodes. We do air every Monday at 2 p.m. Eastern, 11 a.m. Pacific Standard Time. And the topic for next Monday is implementing AWS Cloud Formation. And focused all around the AWS native infrastructure as code solution that we offer. Sukhmeet, pleasure having you here today. Thanks so much for your time.
Thanks, Clint. I appreciate the opportunity, and thanks everyone for tuning into the show today. Appreciate your support. Thanks.
That's my cue to say happy cloud computing.